recording.
Yeah. Good evening, Professor. These are project about the adding feature to the credit adoption fee with the credit card from the customers. Our team members are Enio, myself, Duggirala, Shekar, Reddy, and the Ragul Kumar. Yeah, the main goal of this project is that we are enhancing the existing the web-based adoption platform, which provides seamless and secure payment experience for the user adopting pets. By integrating a future to color adoption fee securely with the credit card, we in this one we aim to streamline the adoption process and promote responsibility for the pet ownership. The existing feature is that the current platform it facilitates the adoption of the pets by connecting user with the regional animal shelters and rescue groups, and it also allows user to browse the available pets which are ready to adopt, and we can the customer can easily view the detailed profiles and interest inquiries to the shelters or the rescue groups. And what the we proposed future is that our future it allows adopters to submit adoption fee using a credit card through the platform, and this future is enhancing the convenience for the users, which ensuring the secure handling of payment information. And in this project, we utilize several tools and technologies to enhance this functionality and security. And as coming to this tools which are used in this project are Microsoft Azure, which are used for the Azure SQL database, which is used for the securely storing data with firewall configurations to restrict access and to authorize users only. And Azure App Service we use to hosting environment for the application, ensuring a secure and encrypted data transmission compliant with the PCI standards. And we use the Azure Key Vault, which encrypts and manages the keys and secrets used in encryption of the credit card data from the customer, and as well as the we use for the PaySafe API, which was a integrated process in the payment transaction which are made by the customer to securely enabling the collection adoption fee via credit card which are used by the customer. And in this and for the GitHub actions used for the continuous integration and continuous deployment CI/CD, automating the deployment process to Azure App Services, which ensures efficient and error-free deployments. And we use JavaScript library for the Notch Frost used for implementing the RSA encryption algorithm, which encrypts credit card data during transmission. And the front-end development used for the React is providing a robust and dynamic user interfaces. And coming to the Logic app, uses the backend component using the conjunction with Azure Key Vault for the decryption of the encryption data. These are technologies we use in this one. Now I'm transferring to the Enio. Thank you.
From here, I will take on forward. The main objective of the project is to make it PCI DSS resilient and to provide the robust security of the credit card systems. As part of PCI DSS compliance, we have 12 requirements. As it is not a real world project, real world scenario, it's not in a large scale infrastructure. We have some, we are not able to implement some requirements as we don't have the credit card devices and all. We made a list of 4 feasible regulations for our projects. Requirement one is install and maintain a firewall configuration to protect the data. Here we used Microsoft Azure QL to achieve this goal, and then protect the we use Microsoft SQL Server to store the data. We encrypted the transmission of cardholder data across from client to server and decrypt in the backend. We use REST API to achieve this goal, and then to restrict the physical access to the cardholder data, we set up a firewall and restrict the access and physical. We had all physical meshes. Microsoft Azure itself has a physical access issues, and my friends will talk further more about this in detail. From here, Eno will take forward.
There we go. All right, we're gonna go over the approaches that we implemented into this project. So the first one, I'm gonna dig a little bit more about the details. The first one was the firewall configuration. So our approach was in the Microsoft SQL Server. we basically enable the firewall in order to accomplish and meet with this regulation. So I'm gonna go ahead and jump into our Azure subscription that we have through the university through FIU. So I'm gonna go over the resources allocated for this project. We created a resource group, and inside the resource group, we have the database, which is this one, the Pet Adoption App. In this is the database where we save or store all the information related to this application. So we enable the firewall here, and we are restricting the access to the database just to these IP addresses. So in that way, we can restrict or enable or disable, manage the access to the users that need to read data from the database in order to regulate who can read the credit card information stored. Well, we are not saving the credit card, but just to restrict access to this resource. Let me go back to the second section. So the second approach, or the second requirement that we implemented, which is the number 4 in the initial list, was the credit card data encryptation. So we are encrypting the data from the client to server, as Raja mentioned. So we are using in the client component, we are using React, and we are leveraging the encryptation process with a library that the name is NodeForge. This library facilitate the process of encryption using RSA algorithm. RSA algorithm is an algorithm that is acceptable by the PCI Standard Council as an algorithm to encrypt the data. So it is important to mention in this section that we are just encrypting data from client to server. We are not storing the credit card information in the database. So Ragul is gonna talk a little bit more in detail in that particular section. But I'm gonna go over to a demonstration in how we accomplish this. So I'm gonna go into the front-end app in our local. This one are running in the server. So I'm gonna go into this one, which is my local. Since the code is already compiled, we cannot see the source code in this resource. This one is production, is a public URL. This one is my local. So I'm gonna go over the process of that we follow in order to encrypt the data. I'm gonna go over this screen. So over this screen, you know, a quick description in this screen is it shows the details of the pet, and we have a form in this section that allows to send an inquiry to the shelter. So we adjust this piece of the application in order to capture the credit card information. And once we capture the credit card information, we encrypt that data in the client, and we send that information to the server encrypted. So I'm gonna run into the demonstration here. I'm gonna use the autocomplete feature to go a little bit faster. Let me just make sure that this pet is available, okay? I'm gonna auto-populate all this information. All right, so in this section, I'm gonna fill out the credit card number. The approach that we took in this project is an integration with Paysafe. Paysafe is our credit card processor provider that we use to accomplish the integration of the credit card processing. So as part of the documentation, they provide testing credit card numbers in order we have a demo account with them that we are using in this project to simulate the credit card charge. So I'm gonna use one of those credit card or those testing credit cards, and this information is not validated as part of the demo environment that we have with them. So we have a breakpoint in the code where we can see exactly where is this process done. So I'm gonna send the request to the backend. So here we have a breakpoint in the application, and we can see as part of the logic that we have implemented, the RSA algorithm require a public key that is generated by the receiver. The receiver is our key vault in this case. We already configure the public key in the code, and we are encrypting all the fields related to the credit card. So if we see the information that we are sending to the server, all the credit card information is already encrypted. So as we see here, so the credit card expiration month, year, name, number, city, well, the credit card number are encrypted. So it is not human readable. And this is using the RSA algorithm in our code to accomplish this task using the public key provided by Azure. So once we send this request to the backend, I'm gonna go ahead and keep running the application. So this one is gonna go to the backend now. And we are using in our backend Azure Logic Apps in order to implement this project. So the Logic App that received this request is this guy over here. So this is the last request is the one that we received. Today is 4/26, April 26. This is the request that we just sent from the front end or from the client. As part of the step that we follow in this implementation, we receive the request is the first step. We receive this JSON payload, and this contain all the information that we saw in the client side. So all this information is encrypted. So the following step is decrypt all those fields. So as part of this process, we have the name that resource, which is the key vault, receive the encrypted data as an input, and the output is the raw data. So basically is the message or the plain text that was sent from the client. And the same approach is implemented for all the fields. So this is the credit card number where we decrypt the credit card information, and this is the encrypted data, and the output is the credit card number. So we do the same process for all the fields, and when we get all the decrypted data, so we send that information to PaySafe, which is our credit card processor. So as we see, we are calling their API, it's the testing environment, and we are sending all the payload or with all the information required and the structure that is required by them in order to accomplish this integration. And we receive a response from there that the process was completed successful. And we just store the transaction ID of this request. So we don't store the credit card information as part of the process that we follow here. So let me go into, I wanted to go into the database to show the record that was added. So this is our database. This is the pet adoption app database. And here we are storing all the requests related to the application. Here in this particular record was the one that we just sent. It has the date of today. And this is the transaction token that was generated by PaySafe. Let me go back into our environment here. Okay, this is the process that we follow, and then we just store the data in the upcoming step, and we update some of the information. We send the email as part of this flow. But the key part is the encryption and decryption information here. So that having that implementation in place, we comply with the regulation that we mentioned in order to encrypt the data from the front end to the back end. So I'm gonna pass by to Ragul.
Yep. So I think we are talking about the next requirement which we have implemented, which is to protect the data while in transaction and when we are storing. So to achieve this, we are using Azure App Service, and we are also following one of the PCI compliance standard, which is not using the vendor provided security parameters or vendor provided passwords to the system. So, and along with that, as as my TV states, we are using Azure Azure services. So in this Azure services, it comes with PCI compliances of 3.0 and 3.1, which has the data protection against the uh, data breaches. So this Azure App Services provides a secure hosting environment and during the transmission between the data from the front end and the back end, so which adheres to the PCI standards, and it also adheres to some other standard regulations like ISO and IEC 2000 27001, so which is a regulation to protect personal data, which is a credit card data, and it also adheres to some other regulations like FedRAMP, which is US Federal Risk and Authorization Management System programs. So these are the things which we have considered and implemented in the app. So to maintain this to implement this requirement 3, secure transmission, and moving on to the fourth requirement which we have implemented, where the restriction of data to the cardodal data. So here, which us Enio side, we have integrated PaySafe integration is one of an third-party tool which we used here to handle the credit card transmissions. So this PaySafe has several unique aspects like card payments, customer vault, hosted payments, and 3D secure security transactions. So this is one of a reliable software which can handle our payment transaction, and it can store the credit card data in a separate server, and which allows us to give the token which we can store in our particular database. So which restricts the direct physical contact or a direct connection to the credit card data, so which can access by any criminal actors. So this is where we implement this cutting off the accesses to the actual credit card data directly. So by using this PaySafe during our testing phase, we came across lots of scenarios, and we did a lot of testing with dummy accounts which were provided by the PaySafe to check our integration with our website. It is working fine, and during that testing, we found out all the transaction happening, and then we didn't moved on to the production after successful and seamless testings. So this is how we have implemented the fourth requirement. So here, why we are going for the not storing the credit card data in the same database where we are storing all the customer details. So one of the PCI compliance regulation says that the data which we are gathering from the client about the credit card, it should not be stored together. So it will be easy for the criminal actors to access the credit card data if all the data are in a single database which can provide all the details together. So here we are achieving that also, that one of that particular point of PCI compliance DSS. And after that, why PaySafe? So here, why PaySafe is like this. PaySafe has a lot of functionalities, so it can handle lots of payment transactions, and one of the main feature is like it has a customer vault and a 3D secure program where it has implemented SHA 256 security standard encryption models which handle data transaction securely. And apart from that, so there is one more thing. So to protect the data against the data breach, so which is the main point again we are quoting here. So to handle the data which is very sensitive, so to separate the data from the actual transactions, we are using this PaySafe. So after that, how we achieve this? So to achieve this, we did continuous integration and deployment. So while integrating this API of PaySafe into our system, we did manual testing with lots of data, and thereby we achieved this data data isolations from the actual database. So below are the this is the GitHub repository, which where the code is being uploaded, and the tested code and the links are there. And this is the overview of the the web page, and the software source code explanations are here.
Yeah, as part of the, just to clarify, as part of the CI/CD process, we use GitHub Actions to deploy the artifact to the Azure resource. So this is the deployment process where we build the application, the code that is hosted in this repository. We build the project and we deploy the project to the production environment, which is a public URL, which is this one. This URL is basically, as Ragul mentioned, an app service that is hosted in Azure that comply with the regulations. Let me go ahead and show the app resource that we are using. If we go into the app resource, is right here. This is the app resource. If we go back, so this is an app service. As part of the documentation that we showed before, the app service comply with the PCI standard 3.1 and 3.3.0. And yeah, this is the app service, which is the same. It provides the public URL, but the public URL by default, and it already have out of the box the TLS configuration, encryption process already implemented. So if we go to the same URL, is the application that we were using here. Yeah, and regarding to the PaySafe integration, I forgot to show here the transactions that we basically charge into the credit card. We can see all the transactions that we simulate from our client, and this is it provides the token ID, the transaction of the ID of the transaction, and this is the information that we store in the credit card. We are not storing the actual credit card number in this process. Yeah, the source code, as Ragul mentioned, is already published in the GitHub repository. We are providing the link as part of the documentation. We are providing also the documentation of the code base that we use in this project. It's a documentation of the application that we built at the beginning that provide all the features. And we also are providing the public URL to the application, which is hosted, as we mentioned, in Azure. So we describe some of the benefits that Ragul already mentioned of using PaySafe as a credit card processor. Yeah, and to conclude our project, by adding the feature to collect the adoption fee with a credit card and ensuring the compliance with the PCI DSS regulation, the paid adoption platform enhanced the user experience while prioritizing the security of sensitive payment information. This improvement aligns with the project's objectives of promoting responsible pet ownership and improving the adoption process. The integration of PaySafe payment processing solution not only enhanced the platform functionality, but also reinforced its commitment to provide the secure and user-friendly adoption experience. With this implementation of advanced encryption techniques and adherence with the PCI DSS standards, we ensure the confidentiality and integrity of payment transaction, thereby fostering trust and confidence among user and stakeholders. Well, Professor, thank you for your time, and yeah, I hope that you enjoyed the presentation. Thank you.
Thank you, Professor. Thank you.
Thank you.
Thank you, Professor.